This shouldn't be happening. The mystery of Comet 29P. Something strange is happening in the outer reaches of our solar system. Just beyond Jupiter's orbit, a single object has been exploding again and again for decades. No warning, no pattern, no clear cause. It brightens by hundreds of times within hours, ejects over 1 million tons of debris, and then falls silent until it happens again. And here's the strangest part. This isn't a comet approaching the sun. It isn't being torn apart by gravity or heat. It's just floating out there, in a nearly perfect circular orbit, behaving like nothing else we've ever seen. So what's really happening? Is it alive in some strange geological way? Is there something inside, something we've missed all along? And could this mysterious object be the most active volcanic body in our entire solar system, second only to Jupiter's moon Io? Today, we dive into the mystery of Comet 29P Schwarzmann-Walkman, also known as Centaur 29P. Why does it erupt so violently? And what has the James Webb Space Telescope recently revealed that's forcing scientists to rethink everything we thought we knew about icy bodies in space? Let's find out. The discovery, a centaur among giants. The story begins almost a century ago. In 1927, two astronomers at the Hamburg Observatory, Arnold Schwarzmann and Arno Arthur Walkman, discovered a faint, slow-moving object while comparing photographic plates of the night sky. At first, they thought it was an ordinary short-period comet. But as time passed and its orbit became clearer, the classification changed. 29P wasn't like other comets. It didn't plunge toward the sun in a long, elliptical path. Instead, it stayed between the orbits of Jupiter and Neptune, tracing a nearly circular route around the sun every 14.6 years. That placed it in a strange category known as centaur objects named after the mythical half-human, half-horse creatures of Greek legend. And the comparison is fitting. Centaurs are hybrids part asteroid, part comet. They originate in the Kuiper Belt, far beyond Neptune, but gravitational nudges from the giant planets occasionally drag them inward. Once that happens, they become unstable transient visitors to the inner solar system, destined either to fall toward the sun or to be ejected into interstellar space forever. Most centaurs are quiet, frozen, dim, but 29P is something else. It's one of the largest centaurs, known about 60 kilometers across, wider than 96% of its kin, and it's one of the most active objects in the entire solar system. It erupts on average 30 times every year, and 40% of those explosions happen without any warning or pattern whatsoever. No other known comet behaves like this. It's like a cosmic volcano, erupting in the darkness between worlds. The explosive mystery. Each outburst is dramatic. Within just 2 or 3 hours, 29P can become hundreds of times brighter. Sometimes it bursts 4 times in just 2 days. In 2024, it did exactly that, 4 eruptions in 48 hours, making it nearly 300 times brighter than usual. 2 years earlier, it expelled more than 1 million tons of debris into space at supersonic speed. Imagine the most pressurized champagne bottle in the universe being uncorked. And that's not all. Often, one major explosion is followed by 2 smaller ones. About 5 to 7 days later, as if something underground continues to rumble long after the main blast. Astronomers have recorded dozens of these events, but the largest on record happened in September 2021, the most powerful eruption in 40 years. And who first spotted it? Not professional astronomers, but amateurs. Enthusiasts with backyard telescopes saw it flare up before observatories even knew something had happened. That's part of 29P's strange charm. It's unpredictable, and yet so visible that skywatchers across the world can catch it in action. Professional observatories then scramble to study it, fighting for precious telescope time, because who would approve a multi-million-dollar space observatory to watch an object that explodes at random? But sometimes luck is cruel. Just one day before Hubble was scheduled to observe 29P in 2021, it malfunctioned. The telescope went offline, missing the show entirely. Cryovolcanism, the ice volcano theory. So, what causes these outbursts? If you're thinking volcanoes, you're not far off, just not the fiery kind. 29P is what scientists call a cryovolcanic comet, an object covered in ice, with volatile gases like carbon monoxide and carbon dioxide, CO, trapped beneath its surface. Over time, sunlight penetrates the outer shell. It warms the interior just enough to make some of that ice sublimate transform directly from solid to gas. Pressure builds beneath the surface, and eventually, boom, the crust fractures, and jets of icy gas erupt violently into space, carrying dust, frozen water, and other materials with them. That mixture cryomagma is essentially a cocktail of frozen ammonia, water, methane, and nitrogen. It's beautiful and terrifying. Now, you might wonder, why doesn't this happen in all comets? The answer lies in 29P's gravity and rotation. Its escape velocity is relatively high, meaning not all of the ejected debris escapes into space. Much of it falls back, reforming the crust after each eruption, essentially resetting the system for the next explosion. That could explain why smaller eruptions often follow big ones. The surface collapses under its own debris, sealing the cracks, until pressure builds again. A self-repairing cosmic geyser. The circular orbit problem. But there's a problem. Most cryovolcanic comets orbit the Sun in elongated ellipses, which means they heat up dramatically as they approach their closest point, triggering eruptions. 29P doesn't. Its orbit is nearly circular. It stays the same distance from the Sun all year round. That should mean stable, predictable heating and no sudden explosions. And yet, it behaves like a ticking bomb. Why? Why does it erupt so violently when it shouldn't? For years, scientists have tried to find a pattern in its madness. Some noticed that large eruptions often occur roughly every 57 days, matching its rotation period. Could it be that sunlight periodically hits a volatile patch on its surface as it spins? Maybe. But smaller eruptions also occur every 30 or 90 days, too irregular to fit a perfect cycle. It's almost as if the comet has seasons, internal pressure cycles, or hidden fractures deep within. A breakthrough prediction. In April 2023, something extraordinary happened. Astronomers noticed that 29P was dimming its gas emissions, slowing down. They suspected that pressure might be building inside. They made a bold prediction. It's about to erupt. And that same day it did. A small explosion, perfectly timed. It was the first ever successful prediction of an outburst from this chaotic object. For the first time, we weren't just reacting to the randomness, we anticipated it. Science had finally caught up to the madness of 29P. Enter the James Webb Space Telescope. But the real game changer came in 2024. For years, scientists believed that carbon monoxide gas was the primary driver of 29P's eruptions. After all, CO is extremely volatile. It turns from ice to gas even at -248 degrees Celsius. But the James Webb Space Telescope changed everything. Using its near-infrared spectrograph, Webb observed something no one had ever seen before. Not one, but two jets of carbon monoxide, one pointing toward Earth, another toward the north. And in addition to that, Webb detected two separate jets of carbon dioxide, one to the north, one to the south. This was the first definitive detection of CO on 29P. This dual jet structure suggested something incredible. 29P might not be a single uniform object. It could be a fusion of multiple bodies, stitched together in a slow cosmic collision eons ago. Each fragment might retain different ices, compositions, and internal structures, each capable of erupting independently. That would explain the unpredictability. It's not one volcano, it's dozens, each waiting for its own turn to blow. The amorphous ice hypothesis. But Webb's data also led to a deeper puzzle. Why is there so much carbon monoxide trapped beneath the surface when it should have escaped millions of years ago? Here's one fascinating possibility: amorphous water ice. On Earth, ice is crystalline, its molecules neatly arranged in repeating structures. But in the freezing outer solar system, water freezes differently. At temperatures below 77 Kelvin, -196 degrees Celsius, it forms amorphous ice, a porous, chaotic structure that can trap gases within it. When that ice warms and becomes crystalline, the trapped gases are violently released. If 29P still contains large pockets of amorphous ice, each region could act like a time bomb, waiting for enough warmth to trigger conversion and an eruption. A matter of scale. Here's where size becomes everything. Smaller centaurs, just a few kilometers across, would have long since converted all their amorphous ice into crystalline ice. That process takes only a few million years. But 29P is massive. Models suggest it could take 60 to 100 million years for all its amorphous ice to fully crystallize. At its current location, only about half of it has done so. That means half of its interior is still unstable, full of trapped gas under pressure. Each patch that crystallizes could release sudden jets of CO, cracking the surface, shaking the crust, and hurling debris into space, over and over again. And when parts of the surface collapse back down, sealing the fissures, the cycle begins anew. The chaotic heart of 29P. Some scientists suspect that these structural changes, collapses, sinkholes, and landslides inside the nucleus may be the real engine behind its unpredictable nature. But there's still something missing. Even if crystallization explains the gas, how does the pressure build up so quickly enough to cause multiple eruptions a year? The truth is, we still don't know. 29P refuses to fit into any of our models. It shouldn't behave like this, and yet it does. Perhaps deep beneath its frozen crust, a slow, rhythmic breathing occurs. Pockets of ice melting, refreezing, collapsing again. A kind of heartbeat in the darkness. The cosmic significance. Why does any of this matter? Because 29P might be showing us how the early solar system behaved when ice, rock, and volatile gases interacted chaotically in the cold frontier beyond Jupiter. Studying it helps us understand planet formation, cryovolcanism, and the strange chemistry that might one day lead to life on other icy worlds. In many ways, Centaur 29P is a living fossil of the solar system's infancy, a frozen relic that still moves, still breathes, still surprises us. And thanks to telescopes like Webb, we're finally peeling back its layers one explosion at a time. The final mystery. Why does it keep erupting? Why so violently, so often, so unpredictably? Every answer only leads to more questions. Is it possible that 29P isn't just a remnant of the past, but a preview of the future, of what will happen when our own icy worlds begin to die, fracture, and vanish into the dark? Perhaps what we're witnessing isn't chaos at all, but transformation. Maybe this is what happens when a world tries to hold on, when trapped energy from the dawn of the solar system still struggles to escape. So what do you think? Is 29P a single unstable comet, or a cluster of icy fragments colliding from within? Could amorphous ice really explain its wild behavior, or is there something even stranger we haven't discovered yet? Let me know what you think in the comments. Because somewhere beyond Jupiter, a lonely world keeps exploding in silence, and no one truly knows why. Thanks for watching. If you enjoyed this deep dive into the mysteries of our solar system, subscribe for more stories that remind us how little we really know about the universe we call home. See you next time under the same silent stars. Ten strange things happening in the universe right now. Something is off. Not in the distant future. Not in theory. Right now. Across the universe, objects are appearing where they shouldn't exist. Energy is reaching us from places it should never escape. Signals are arriving that challenge everything we think we know about physics. Some of this sounds like science fiction, but every story in this video comes directly from real observations. Today, we're looking at 10 strange things happening in the universe right now. Discoveries that are quietly reshaping our understanding of reality. 1. We are tracking something that shouldn't be here. Astronomers around the world are currently watching an object that doesn't quite make sense. It entered our solar system from interstellar space, moving far faster than most known comets. Its trajectory points back toward the constellation Sagittarius, and its speed suggests it could be older than the solar system itself. The object is known as 3I Atlas. Officially, scientists classify it as an interstellar comet, but its unusual motion immediately caught public attention. Online, speculation exploded. Some people suggested it could be a probe. Others called it a scout, or even a message. Researchers dismissed those ideas. Still, they admit the object is unusual enough to deserve close monitoring. In 2026, Atlas will pass near Jupiter. That encounter could dramatically alter its course, either ejecting it from the solar system or sending it in a new, unexpected direction. Two, something is launching high-energy particles at us. Earth is constantly being bombarded by particles traveling at nearly the speed of light. They're called ultra-high energy cosmic rays. When they hit the atmosphere, they explode into showers of secondary particles, leaving behind detectable traces. That's how we know they exist. What we don't know is what fires them. Supernova are a strong candidate. So are black holes, neutron star collisions, and the cores of active galaxies. The problem is that these particles twist through magnetic fields during their journey. By the time they reach Earth, all information about their origin is erased. We know we're being hit. We just don't know by what. Three, gamma rays we shouldn't see reached us anyway. In 2022, space lit up with the brightest cosmic explosion ever recorded. A distant star collapsed into a black hole and released a gamma ray burst so powerful it earned the nickname, GOAT, brightest of all time. Some of the detected gamma rays carried more energy than our models say should survive a journey across billions of light years. According to known physics, they should never have reached us. Yet they did. One possible explanation involves dark matter. Some theories suggest gamma rays may interact with exotic particles, allowing them to shift states and travel farther than expected. If true, this event didn't just break records. It may have revealed a hidden layer of the universe. Four, the cosmic microwave background might not be alone. For decades, the cosmic microwave background has been treated as the oldest light in existence, the afterglow of the Big Bang. But recent research suggests something unsettling. A small portion of that glow may not come from the Big Bang at all. Instead, it could include light from extremely ancient galaxies, blended into the background signal. Not enough to rewrite cosmology, but enough to raise an uncomfortable question. Have we fully separated the universe's earliest light, or have we been looking at a mixed signal this whole time? With more detailed maps coming soon, scientists may finally find out. Five, black holes are turning up all around us. Astronomers have long known about this supermassive black hole at the center of the Milky Way. Now, evidence suggests there may be another one surprisingly close. Researchers studying stars near the Large Magellanic Cloud noticed something strange. Some stars were moving far faster than expected, fast enough to escape the galaxy entirely. That kind of speed requires an enormous gravitational push. By tracing the star's motion backward, scientists identified the likely culprit, a black hole roughly 600,000 times the mass of the Sun. If confirmed, it would be the closest supermassive black hole ever detected outside our galaxy. Six, the universe might be rotating like a giant wheel. When astronomers study some of the oldest known galaxies, they notice a pattern. A large majority of them rotate in the same direction. Not a slight preference, nearly 2/3 spin clockwise. That raises a surprising possibility. What if the universe itself began with a built-in rotation? We already know rotation is everywhere. Planets spin, stars spin, galaxies spin. Extending that motion to the universe as a whole is a bold idea, but the data is forcing scientists to consider it. If the universe started with a spin, it could explain why motion appears at every scale. Seven, the Milky Way might be trapped in a gigantic void. There's a long-standing mystery in cosmology known as Hubble tension. When scientists measure the expansion of the universe using nearby galaxies, they get one speed. When they measure it using the early universe, they get another. Both methods are reliable, yet the numbers refuse to match. One possible explanation is unsettling. What if the Milky Way sits inside a massive cosmic void, a region with fewer galaxies than average? In that case, denser regions outside the void would pull outward more strongly, making nearby space appear to expand faster from our perspective. If true, the universe itself isn't behaving strangely. Our location is. Eight, we're using fast radio bursts to find hidden matter. For years, half of the universe's ordinary matter was missing. We could see stars and galaxies, but not the faint gas between them. Fast radio bursts changed that. These incredibly powerful flashes travel billions of light years. As they pass through intergalactic gas, their signals stretch and slow. By measuring that distortion, astronomers can calculate how much matter lies between galaxies. It's not a perfect map yet, but it's the closest we've ever come to locating the universe's missing material. Nine, the universe is showing signs of self-organization. For something born in chaos, the universe is surprisingly organized. Galaxies form long filaments. Clusters assemble into vast cosmic webs. Matter arranges itself into repeating patterns. This doesn't look random. It looks procedural. Similar patterns appear in living systems, from cells to ecosystems. On the largest scales, the universe behaves less like an explosion and more like a system slowly arranging itself. 10. It's also evolving. Early space was simple, mostly hydrogen and helium. Today, it's filled with heavy elements, planets, oceans, and chemistry complex enough to support life. Each generation of stars creates new materials. Explosions forge metals. Metals build planets. Planets create environments. That's evolution, just not biological. It's possible that evolution didn't start with DNA. It may have started with physics itself. And this is only the beginning. In the next video, we'll explore 15 even stranger discoveries. From planets forming without stars, to lava oceans on distant moons, to hidden water deep inside Mars. The laws of physics might not be permanent. We tend to think of the laws of physics as eternal, fixed, unchanging, as if they were written into the fabric of reality once and forever. But what if they aren't? When scientists look deep into the universe and far back in time, something unsettling appears. The fundamental constants that govern reality may not be as stable as we assume. Constants like the strength of gravity, the charge of the electron, the fine structure constant that controls electromagnetism. These numbers determine whether atoms can exist, whether stars can form, whether chemistry and life are even possible. And yet, observations of distant quasars suggest that at least some of these values might have been slightly different billions of years ago. Not dramatically different, just not identical. Even a tiny change would rewrite the entire universe. If gravity were slightly stronger, stars would burn out too fast. If electromagnetism were weaker, atoms might never bond. If nuclear forces shifted, no carbon would exist at all. Which leads to an uncomfortable question. If the laws of physics can change, then were they ever truly laws to begin with? Or were they closer to conditions, temporary rules that emerged as the universe evolved? This idea shakes the foundation of physics itself. Because if laws can evolve, then the universe is not a static machine. It's a process, and processes have histories. The universe remembers its past. The universe is often described as forgetful. Stars explode, galaxies collide, structures rise and vanish. But when scientists map the cosmos carefully, they notice something strange. The universe remembers. The cosmic microwave background, the faint afterglow of the early universe, still carries tiny temperature patterns imprinted just 380,000 years after the Big Bang. Those patterns didn't fade. They didn't blur away. They became the blueprint. The filaments of galaxies we see today follow those ancient fluctuations almost perfectly. Vast clusters formed where density was slightly higher. Cosmic voids opened where it was slightly lower. In other words, the universe never reset. Every stage left an imprint on the next. Even more strangely, some large-scale structures seem too organized to be random leftovers. Certain alignments stretch across billions of light years, preserving directional information from a time when the universe was unimaginably young. That means the present universe is not just shaped by physics. It's shaped by its memory. And memory is not a passive thing. Memory influences outcomes. It constrains what comes next. Which raises a deeper question. Is the universe merely expanding? Or is it carrying its past forward, shaping its own future? "13. Order keeps emerging from chaos. The universe began in violence, extreme temperatures, relentless expansion, constant collisions. By all classical logic, chaos should dominate. And yet, everywhere we look, order keeps forming. Particles arrange themselves into atoms, atoms into molecules, molecules into stars, planets, and structured systems. Galaxies don't scatter randomly. They line up along vast filaments, forming a cosmic web that spans the observable universe. This kind of order shouldn't appear so consistently, not without guidance, feedback, or self-correction. In nature on Earth, we see the same pattern. Snowflakes forming perfect symmetry, crystals organizing from molten chaos, ecosystems stabilizing themselves over time. Physics explains how these patterns form, but it doesn't fully explain why order keeps winning, why complexity doesn't just collapse back into randomness, why structure appears again, and again, and again. At some point, coincidence stops being convincing. "14. Complexity keeps increasing. Early universe. Simple. Hydrogen, helium. Almost nothing else. Today, planets with atmospheres, chemistry, oceans, biology, technology. This is not a neutral trend. It's directional. Each generation of stars creates heavier elements. Those elements form rocky worlds. Rocky worlds enable chemistry. Chemistry enables biology. And biology enables observers, beings capable of asking questions about the universe itself. That trajectory looks disturbingly similar to evolution. Not biological evolution, cosmic evolution. The universe doesn't just change, it builds. Each stage enables the next, and once complexity appears, it rarely goes backward completely, which leads to an unsettling thought. Maybe evolution didn't start with life. Maybe life is just one expression of a much older process. "15. Information might be more fundamental than matter. Here's where things get truly strange. In modern physics, matter keeps losing its status as fundamental. Particles behave like probabilities. Fields replace objects. Reality seems governed by equations, not substance. And increasingly, physicists are pointing to information as the true foundation of everything. Black holes obey information limits. Entropy measures missing information. Even space-time itself may emerge from informational relationships. Some theories suggest the universe behaves less like a physical object and more like a computation. Not a simulation, that's a separate debate, but a system where information is conserved, structures encode states, complexity grows through processing. If that's true, then stars, galaxies, and even life are expressions of information flow. Which brings us to an uncomfortable realization. Information doesn't arise randomly. It accumulates. It organizes. It propagates. And systems that process information tend to develop structure. "16. The universe behaves like a system. Systems have traits, feedback loops, stability ranges, thresholds, phase transitions. And the universe shows all of them. Too much expansion, structure fails. Too little, collapse. Too much energy, chaos. Too little, nothing forms. Instead, the universe sits in a narrow corridor where stars, planets, and observers are possible, not guaranteed. Just allowed. That balance doesn't mean intention, but it does mean regulation. And regulated systems behave very differently from random ones. "17. Time might be directional for a reason. Time moves one way. Past gives present gives future. Physics struggles to explain why. Most equations work forward and backward. Yet reality does not. Entropy increases. Structures decay. Memory accumulates. But interestingly, complexity increases before decay dominates. Stars form before they burn out. Life appears before extinction. Civilizations rise before collapse. The arrow of time seems tuned to allow structure. Temporarily. Why? 18. The universe produces observers. This is the most uncomfortable fact of all. The universe allows observers. Not just once, not just rarely. Planets form in habitable zones. Chemistry aligns just right. Consciousness emerges. And then the universe becomes aware of itself. This doesn't require design, but it does require explanation. Why is the universe observable at all? Why can its laws be understood? Why do equations written by human minds describe reality so accurately? "19. We are inside a much larger structure. Every time we think we've found the edge, there's more beyond it. Solar system gives galaxy, gives cluster, gives supercluster, gives cosmic web. Each scale reveals another layer. And there is no sign that the nesting stops, which suggests the universe may be part of something larger. Not supernatural, just bigger. And finally, number 20, the question we can't avoid. After everything we've seen, one question remains. If the universe is not random, if it evolves, remembers, organizes, and produces observers, then what is it becoming? And what does that mean for us right now? In 1900, Greek sponge divers made one of the most astonishing discoveries in archaeological history. On the seabed near the island of Antikythera, they found an ancient shipwreck that had sunk about 2,000 years ago. Among marble statues, bronze artifacts, and amphorae of wine, there was a mysterious object, a corroded piece of metal and wood, later known as the Antikythera mechanism. The Antikythera mechanism is the world's oldest known analog computer, built in the 1st century BC. It used a complex system of bronze gears to predict the movement of celestial bodies, lunar phases, and solar eclipses. Its main function was to calculate astronomical cycles and forecast eclipses. One of the key functions of the mechanism was predicting eclipses using the Saros cycle, a Babylonian cycle lasting 223 months, about 18 years and 11 days. This cycle was known to Babylonian astronomers and later adapted by the Greeks for their device. The mechanism also employed the Metonic cycle, a 19-year cycle used to synchronize the solar and lunar calendars. Many researchers believe the Antikythera mechanism was influenced by the work of Archimedes. Cicero mentioned celestial globes created by Archimedes to demonstrate planetary motion and eclipses. Although the mechanism was built decades after his death, its design may have been based on his ideas. Using modern technology, scientists have created working replicas of the Antikythera mechanism. CT scans and 3D imaging allowed for the reconstruction of its intricate mechanics. Today, replicas of the mechanism are displayed in museums worldwide. The Antikythera mechanism was not just a scientific tool, but also served as an educational device for philosophers and astronomers. It symbolized the ancient Greek desire to understand the universe and its cycles, blending science with mythology. The Antikythera mechanism reminds us that even in ancient times, people reached for the stars and sought to understand the laws of the universe. This device was millennia ahead of its time and remains a symbol of ancient engineering genius. The story of the Antikythera mechanism's creation is shrouded in mystery. It was likely designed by a brilliant astronomer or mathematician working in Hellenistic Greece. Archaeologists suggest that it might have been created in the school of Hipparchus, one of the most renowned ancient Greek astronomers. Hipparchus was the first to develop a theory of lunar motion, which was later incorporated into the mechanism. One of the most remarkable features of the Antikythera mechanism is its complex gear system that accounts for the elliptical orbit of the Moon. For the first time in human history, the principle of epicyclic gearing was used to accurately calculate the Moon's acceleration and deceleration. The Antikythera mechanism could predict solar and lunar eclipses with daily accuracy. It also displayed the phases of the Moon and the positions of the 5 planets known to the ancient Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. This information was crucial not only for astronomers, but also for navigation, agriculture, and religious ceremonies. The discovery of the Antikythera mechanism changed our understanding of ancient science. Before its discovery, it was believed that such complex devices only became possible during the Renaissance. It is now clear that the ancient Greeks came close to creating clocks and calculating machines 1,000 years before mechanical clocks appeared in Europe. Modern researchers have created several working models of the Antikythera mechanism. These reconstructions help us understand how the device worked and continue to inspire engineers. In 2012, a team of scientists from Cardiff University built a functional replica, demonstrating just how ingenious this ancient technology was. The Antikythera mechanism has become a true symbol of ancient engineering genius. It appears in scientific films, books, and even video games. This device inspires modern writers and filmmakers who see it not just as a scientific discovery, but also as a source of myths and legends. Today, the Antikythera mechanism reminds us of humanity's quest for knowledge and understanding of the universe. It proves that ancient civilizations possessed knowledge far ahead of their time. Its legacy continues to inspire scientists and engineers around the world. Ancient sailors relied on the stars for navigation, and precise knowledge of celestial positions was essential for successful voyages. The Antikythera mechanism could have been used to calculate lunar and solar cycles, making it easier to predict weather and determine the time of year. It also helped track the positions of planets and identify favorable dates for embarking on maritime journeys. Interestingly, the Antikythera mechanism incorporates astronomical cycles similar to those used by the Babylonians. One of its key elements is the Saros cycle, lasting 223 lunar months, about 18 years, which was used to predict eclipses. This proves that the ancient Greeks not only relied on their own knowledge, but also borrowed from other civilizations, such as the Babylonians and Egyptians. The Antikythera mechanism has become a symbol of innovation and an inspiration for modern technology. Its principles form the foundation of mechanical clocks, analog computers, and even modern astronomical instruments. Scientists continue to study the device, applying its ideas to create new tools. In the 21st century, it has become a key feature in educational programs and museums worldwide. The Antikythera mechanism is not just an astronomical device, but also a reflection of ancient Greek philosophy. For the Greeks, stars and planets were closely tied to mythology and religious rituals. The mechanism might have been used to explain celestial phenomena in the context of myths and legends, helping students and philosophers better understand the connection between the cosmos and human life. The Antikythera mechanism is not just an archaeological find, but a true window into the past, revealing how deep ancient knowledge truly was. Its existence shatters many stereotypes about ancient technology. For a long time, we believed that such complex mechanisms appeared only in the Middle Ages, but the Antikythera mechanism proves that ancient engineers were capable of incredible inventions. What's even more fascinating is the thought that such a device could have changed the course of history if its technology had developed further. Imagine an alternate reality where ancient Greece created early clocks, astronomical computers, and even mechanical calculating machines. The Enlightenment might have arrived 1,000 years earlier, and space exploration could have begun in antiquity. Today, the Antikythera mechanism is not just an artifact, but a symbol of humanity's timeless quest to understand the universe and find its place within it. It inspires scientists, engineers, and historians to seek new knowledge and discoveries, reminding us that even the most ancient inventions can be the foundation for future technology. The enemy, that you can't see it, and what would happen if that same type of mirror. Why? Grandma is often referred to as the invisible castle does not roar, it does not burn, it does not collapse buildings. Simply passes through the people of Ukraine and Belarus, who experienced the catastrophe of 1986. At the U.S. nuclear power plant, they recall something disturbing right after the explosion. The sky was a perfect blue, the air seemed clean, fresh, almost comforting. Nothing warned of danger, and yet, while breathing deep into that air, apparently pure, invisible particles through their bodies without resistance, damaging cells, breaking DNA strands, initiating irreversible processes. Many of them did not die that day. They died later, slowly now. Let's imagine something even more disturbing. Were not the result of an accident. What would happen if she had been intentionally released, specifically designed to kill the major, possible number of people, without destroying the city? And even more disturbing, what would happen if this idea did not come from a civilization, alien but of human scientists? Brilliant images, normal people. Welcome to one of the stories of the era. Welcome to the world of the neutron bomb. A bomb different from all the others. From the point of view of nuclear physics, the neutron bomb is not a fantasy, nor an anomaly in its basic structure, is strikingly similar to that of a conventional thermonuclear bomb. Both operate in a two-stage design. In the first, a small nuclear fission device acts as a detonator plutonium, divide violently, releasing energy in a chain reaction that generates extreme temperatures. That energy activates the second stage in a nuclear fusion reaction, where light cores combine to form cores, releasing a colossal amount of energy. So far, nothing out of the ordinary. The difference appears in the purpose. While in a hydrogen bomb, most of the energy turns to heat, evil, expansive, and electromagnetic pulse. The neutron bomb is designed to prioritize aggression, in particular, the radiation of high-energy neutrons, the role of tritium, and invisible death. To achieve this effect, a key substance is used, and tritium is a radioactive isotope of hydrogen, with a half-life of just over 12 years in a bomb. Standard nuclear power, only a few grams are used. In a neutron bomb, the quantity is several times greater than the result. Is disturbing. Only about 20% of the energy released manifests itself as an explosion, heat, or structural damage. The remaining 80% is released as neutrons. Ultra-fast. These neutrons pass through shield walls, concrete, steel, and also pass through human bodies. Do not burn the skin, do not demolish buildings, but they destroy from the inside. Why would anyone want to create something like this? During the Cold War, the military strategists faced a disturbing, even if they won a nuclear war, what would be left after two? Razed cities, unusable infrastructures, contaminated territories for decades to win, meaning an uninhabitable World 3. In this context, between the 1950s and 1960s, began to emerge a dangerous idea, and if there were a weapon that would eliminate the enemy but left the territory intact. A bomb that would kill people but not cities. The scientist who crossed the line, the main driving force behind this idea, was Samuel Theodore Cohen, a physicist who had worked on the Manhattan Project, the same program that gave rise to the first atomic bomb. Cohen saw no moral contradiction in his proposal. On the contrary, Anne was convinced that her creation, its concept, was more humanitarian, was christened as a weapon of enhanced possession, enhanced radiation weapon. According to his vision, a bomb with less material destruction could reduce casualties, civilians, and avoid catastrophic escalation. Not everyone shared his optimism, from theory to reality. In the early 1960s, testing began in 1963. You successfully detonated a neutron bomb. In a subway test in the 1970s, the weapon officially went into production in 1977. President Jimmy Carter approved its development for NATO forces in Europe. In the early 1960s, tests began in 1963. You successfully detonated a neutron bomb. In a subway test in the 1970s, the weapon officially went into production in 1977. President Jimmy Carter approved its development for NATO forces in Europe. Public reaction was immediate and fierce critical protests. Incendiary publishers, the so-called humanitarian bomb, became a symbol of extreme cynicism. Of modern, production stopped, but only temporarily in 1981. Under Ronald's administration, a perfect weapon in theory. On paper, the neutron bomb seemed ideal for certain scenarios. A bomb of barely 1 kiloton could incapacitate a tank crew more than 1 kilometer away, not even 150 millimeters armor, could completely stop the neutron flux. Soldiers would die. The tank would remain intact, but the reality was less convenient. In the Earth's atmosphere, neutrinos interact rapidly with air, especially with nitrogen, and the mirror's effective reach is reduced. The atmosphere paradoxically protects life as a result of many of the theoretical advantages of the neutron bomb are a new scenario space where the neutron bomb regains its attractiveness is outside the atmosphere in the vacuum of space. Neutrons can travel enormous distances without a close detonation. No direct impact is required. It is enough to brush against a satellite or a warhead. Neutrons damage circuits, cause irreversible electronic failures. The object is still there, but he is dead. No debris, no plastic pollution. Without scrap metal clouds, orbital, this converts the neutron bomb in a tool potentially devastating to space. The moral that was never resolved. Samuel Cohen died convinced that his weapon was a lesser evil. His critics never accepted that logic of dying for survival is not more human than dying by fire. It is just slower, quieter. In addition, the neutron bomb erases a dangerous borderline between conventional weapons and nuclear If a clean nuclear bomb becomes acceptable, then the unthinkable ceases to be so. And when that happens, history tells us that the next line is always crossed. The question that remains, is the neutron bomb exists, has been proven to be unknown and probably is still in storage. The question is not whether it can be used. The question is when and under what justification limited nuclear war is possible. Or any weapon designed to kill en masse is doomed to escape to any moral control. Now it's up to you to decide.